we are going to discuss today the different types of storages. Okay, Amazon storage types. So because in several real-time scenarios, so here your coder, if you are working with a particular project, the project related codes will be stored in these Amazon storages like S3. You may need to have a backup copy of your codes in Amazon Glacier. So the Amazon storage plays a very crucial role. So for a Devops engineer. Okay. So apart from you are getting the needed infrastructure from Amazon, the storage part also you can get it from Amazon for your project. So here we are going to discuss about these storage types, followed with how to launch a Windows server, and let me make it one application like how to configure elastic load balancing applications. These are all the things that is going to be happening.
Okay.
Okay, Amazon storage with how to launch a Windows-based instance and what are all the differences by which you can differ from a Linux-based instance. And third thing, let me do a real-time load balancer. How to configure an elastic load balancer. So this is the agenda for today's session. In tomorrow's session, we are going to start with the concept of Git and GitHub. Okay, the first concept associated with our version controlling system. What is version controlling system? What are all the different types of version controlling system? What's Git and what is GitHub? How Git and GitHub differs by how to configure, how to create repositories. These are all the things that will be discussed for tomorrow. Okay, now let me start with this Amazon storages. So in terms of Amazon storage has been concerned, there are basically 5 types of storage. One is Amazon Instant Storage. And second type of storage is Elastic EBS. We call this EBS Amazon Elastic Block Store. Okay, Instant Store, Amazon Elastic Block Store, and third type of storage is Amazon Simple Storage Service. Which is we call it as a S3. And fourth type of storage is Amazon Glacier, which is an archival storage, which is used for archive source storage. Then we have a EFS, Elastic File System. We call this as Elastic File Storage or Elastic File System EFS. So these are all 5 primary storages associated with Amazon. Okay, so the storages, instant store and elastic block store comes under block storage. And this simple storage services and Glacier comes under object storage. This corresponds to block storage. This corresponds to object storage. And the storage is a file. The last type of storage is a file system based storages. Okay. So our focus will be on elastic block store and simple storage service. These are all the tools that we are planning for. So Balaji, Kumar, you please mute yourself. In case of any doubt, you can unmute. I am getting background noise as disturbances. Thank you. Okay, so now let me have a discussion on what are all the differences associated with these 5 different types of storages and under which application that you need to go for the concerned storages, when you need to go for instant store, when you need to go for EBS, when you need to go for Glacier, etc., etc. Okay, so in terms of Amazon has been concerned, we have already discussed that. Here we have aware of about this instance. Okay, so here for instance, if you want to add a hard disk, in our instance, what we did, we have launched the Ubuntu instance with this micro type. Then by default, we have a hard disk of 8 GB has been allocated to the instance. Here, how from where for that instance, it is allocated with 1 microprocessor and 1 GB of RAM memory. That is Intel Xeon microprocessor and 1 GB of RAM memory, by default 8 GB of storage. Here from where the resources for that instance will be allocated. So here from the underlying physical server. So as I told, the instance is nothing but a virtual machine, okay, which is launched on top of a physical server. So from the physical server, the microprocessor and RAM memory has been allocated. The RAM as well as the CPU will be allocated from the physical server on top of where the instance has been created. So from where the storage is allocated, here the storage refers to hard disk, from where the hard disk is allocated. The hard disk can be allocated in two ways. One, from the physical server. The physical server may have its storage. Let's imagine that if you have a storage of 10 terabytes in physical server, so from 10 TB, volume for the needed 8 GB will be created, and this 8 GB will be mapped with the instance storage. Okay, so the being it is a virtual thing, the physical volume, physical storage will be mapped from the physical server on top of where the instance has been created. That is one way. If the instance is assigned a storage from the storage of the physical server, then type of storage has been termed as instance store. Okay, the storage will be allocated from the physical server. That is called instance store. Then the second type of storage is we have a storage box. We have a separate storage box. It may be a sandbox or it may be a NAS box. Here what we do, so you guys are aware of this storage. Let me take this EMC storage box. So from the storage box, a LUN will be created. EMC SAN storage. It is a bunch of disks. Okay, you have hard disk allocated. So from the hard disk, okay, here these are all the hard disk. From the hard disk, LAN according to your need will be created, and that is mapped. Okay, so if you assign a hard disk from a separate storage, then that type of storage has been termed as EBS, elastic block store. Okay, you have your instance, you have your storage box like a sandbox, storage area network, or it can be a network attached storage. You have a bunch of hard disk here. So here the storage for this instance will be allocated. So according to your need, example, you want to assign 1 TB. 1 TB LAN will be created. LAN stands for logical unit number. You guys have if you are working with this storage. 1 TB volume will be created, and that volume will be mapped to the EC2 instance. Okay. If you allocate storage from NASA SAN storage, then that type of storage has been termed as EBS, elastic block store. The instance storage is one from which the physical server, the underlying physical server, storage if it is assigned to instance, that is instance store, and if it is created separately in a storage box, and if it is assigned to the EC2 instance, that type of storage is elastic block store. Then what's the difference between this instance store and elastic block store? The main differences associated with this instance store and elastic block store is, so if you have an instance store, if you terminate the instance, automatically the data associated with this storage also will be terminated. You will lose the information. The lifetime of your data is associated with the lifetime of your instance. That is, in terms of technical terminology, we call this as a data persistence. Data persistence. So the data persistence will be checked with respect to the lifetime. If the instance is terminated, the data also will be lost if it is an instance store. Whereas if you have your data in elastic block store, if you terminate the instance, it won't have an impact in its storage length. Okay, you have data stored separately. In later cases, what you can do, you can launch another instance. You can launch another instance, and you can map the data with this instance. It is similar to, if you are having a EBS storage, it is similar to storing your data in your external hard disk. Similar to storing your data in your pen drive. Okay, what happens if you are having your data in a pen drive? you are having on a laptop with you, you can insert the pen drive and you can read with it. If the machine get corrupted, no need to worry. You can detach the pen drive. You can attach with another laptop. Okay, so the data won't be corrupted if the laptop to which the pen drive is attached got corrupted. Okay, so similarly, so if the instance you terminate the instance with respect to instance, what are all the activities that you can do? You can stop the instance. You can terminate the instance. Okay, so if you terminate the instance permanently, the instance will be terminated. You can't able to restart. If you temporarily want to switch off your instance, then you can stop your instance and laterly you can start your instance. That you are aware of the basics between this stop terminate. Okay, so in this case, if you terminate, all the data will be erased if it is an instance store. And whereas if you have your data in elastic block store, it won't be lost. So the link alone will be disconnected and the data will be retained. The lifetime of the data is not associated with the lifetime of your instance. Am I making sense? Here, when you want to go for instance store, when you want to go for elastic block store, so if you want the performance to be of high, if you are dealing with some real-time data, if you want the performance of read and write to be fast, and under the circumstances you need to go for the instance store. Why so? Because being data is stored on top of the physical server itself, the transferring of data between this instance and the storage of your physical server is very fast, being it is on the same machine. Whereas if you have your data in a separate storage box and if your instance is configured on top of another physical server, that being it is attached with some communicating medium, transferring of data from this box into this instance will be a little bit time delay compared to that of instance store. Okay, if you need fast response time and if you no need to worry about this lifetime of your data, then you need to go for instance store. Usually, operating system related files will be stored on the instance store. Okay, so if you want the data need to be retained, you are not bothering about the instance lifetime. You want the data need to be retained for a longer duration. So you need to go for the option of elastic block store. Okay, this is the differences associated with instance store and elastic block store. So while launching the instance, while from AMI, I need to choose whether the AMI is EBS based AMI or instance based AMI. Okay, how I can decide that I need to launch an instance store based instance? It is based upon the AMI. By while choosing the AMI itself, we need to choose the AMI need to support the instance. Okay, instance store AMI. Okay, these are all the some of the basic things associated with the differences between instance store and elastic block store. If you have doubts, you can clarify before proceeding into the remaining storages. Is it clear?
Yes, clear.
Yes.
Yes.
Here, the thing is that if you want, yes, okay, please mute yourself. The thing is that if you have instance store or elastic block store, under both circumstances, if you want to perform a read or write of your data, that particular data volume need to be associated with this instance. That is mandatory. Okay, so you have your EC2 instance and you have your storage. The storage may be either an instance store or it may be a EBS. So you need to associate the storage and your instance. Okay, the instance need to be associated with this storage. Then only, okay, so this is your revised, this is your storage hard disk. Then only you can able to perform a read or write activity. Okay, that is the key thing. So without associating this instance store or EBS with the instance, you can't, come on, you please mute. You can't perform this read and write of data. So the third type of storage is, so these storages has been termed as block storage. Here the data has been stored in form of the binary blocks. Okay, you are aware of these blocks, which is the basic unit of storage. Data will be stored in forms of binary blocks. Okay, so to read or write the data, that storage need to be associated with an instance. Okay, these are all here. Differences between this instance store and EBS is with respect to data persistence. The lifetime of the data is associated with the lifetime of the instance if it is IS. Then here in case of EBS, it is detached. There is no association between the data's lifetime and the instance lifetime. Okay, the data will be stored as a separate entity. The third type of storage, we call this as a object storage. What do you mean by object storage? Object storage is nothing but storing the multimedia objects. If you want to store audio, if you want to store video, if you want to store images, these things occupies huge storage space. If you want to store documents, PDF, for all these sort of storages, so you can go for either S3 or Glacier. Both serves for same purpose. S3 stands for Amazon Simple Storage Services, okay, which is mainly one of the most widely used storages with respect to that of cloud storage. Any application that you are going to work with cloud, 90% it makes use of this S3 storages. And what's the difference between S3 and Glacier? So here the S3 and Glacier differs by two factors. One, cost. Then the second factor is performance, read and write performance. So here, in terms of cost has been concerned. So it is almost 1:10 times. For example, let me take this example. If you want to store 1 GB of data, if it is rupees 10 Indian rupees for per month, okay. So for storage, it won't cost that much. Just for example, if you are storing your data in S3, 1 GB of data for a month, if it cost rupees 10, the same thing if it is stored in Glacier, it is rupees 1 per month. Almost 1:10 times the cost is effective. What's the reason behind that? So being Glacier is made up of a commodity hardware, so storage of data will result in a less cost compared to that of S3. Then in terms of being it is a made up of commodity hardware, if you want to read or write, in terms of the performance, read and write performance, Glacier is very slow. Minimum you need to wait for 2 to 4 hours to upload your data and for downloading your data. For both activity, for uploading and for downloading the data, you need to wait for minimum 2 to 4 hours. Therefore, so it is not suited for the applications that couldn't withstand this delay. If your applications are real-time applications, if it want to read and write data in a lightning speed, it is not recommended. Glacier is not recommended. If your application is going to work with batch processing, that is you have data and you can fetch the data and you can work on top of the data, like you can do analytics from the existing data. You have a fast data, you apply some analytics on top of it. Okay, so here in this case your application can withstand this much of delay, then you can go for Glacier. S3, the real-time application uses S3. The real-time read and write, you want to use S3. So the batch processing application, you can go for with Glacier. Okay, it need minimum 2 to 4 hours to upload or download the data. So so that is the basic difference. Cost wise, S3 is high, Glacier is low. Performance wise, read and write, S3 is better, Glacier is lesser compared to that of S3. Okay, so these are all the basic differences between this S3 and Glacier. And what's the difference between these two things? Okay, between these two storages, we have a storage EBS and IS, and we have a storage S3 and Glacier. What is the difference? You know the difference between the EBS and IS. EBS and IS stands for block storage, whereas this corresponds to object storage. S3 and Glacier corresponds to object storage. And what's the difference? If you are using IS or EBS, that it need to be associated with an instance. Whereas if you have your data in S3 or Glacier, it is not mandatory that the data need to be associated with the instance for performing a read or write. Either you can associate with an instance or you can have a direct access of the data if it is stored on S3 and Glacier. Okay, am I making sense? So this storages is meant for storing a huge volume of data. If the volume of data is huge in number, we can opt for S3. If the data is real-time data, if it couldn't withstand this read and write delay, then S3 is the best option. So if your application can withstand this read and write delay, then Glacier is the best option. Why so? Because it is very less cost effective in terms of S3 has been constant. Almost 1:10 times it will less cost. Okay, so the S3 and Glacier need not to be mandatorily associated with the instance. Then how to access the data? So in S3 we have a concept called bucket. Okay, a bucket is nothing but a container. In our operating system, it is similar to analogy is directory, under which you can store your files. Similarly, you can upload your data into. You want to create a bucket. You want to upload the data in your file, maybe audio file, video file, anything. Once you upload the data into this bucket, what happens is a web URL will be assigned to that particular file. For example, you are uploading a video. What happens? A URL will be assigned to the video. So if I want that video has to be shared. Okay, so here if I want that video to be shared to Amar, Balaji and Bhaskar, what I need to do, just I will send the URL to the guys. Okay, then Amar, Balaji, without having a cloud account, they no need to have a cloud account. What they need a device with a web browser. Once they paste the URL, automatically the file that it is uploaded to the bucket will be made viewable by the user to which that I had shared the link. So they no need to have a cloud account. They no need to create an instance to associate with this S3 storage. Directly they can able to perform a read and execute all these activities.
Raman, I have a simple question here.
Yeah.
Actually, I don't understand the what is bucket here. Is it
Okay.
simple hard disk or?
What is directory in your operating system? What is the use of directory?
Yeah, directory is a container of files, right?
Yeah, the same thing.
Folders.
If it is a
Yeah.
you want to create a directory. Under the directory, you will organize all your files. The directory here is termed as bucket.
Okay. Yeah. Fine. Got it.
Okay. So similar to that of a bucket, we have also have a directory in Glacier. Okay, we will discuss. So bucket is a directory under which you want to store the file. Then the bucket name should be unique throughout the region. Okay, you aware of what is region, what is availability zones, what is edge locations. We have already discussed on day one. The bucket name should be unique. Within a region, you can't have a two bucket with the same name. Okay, please make a note. You can't have two bucket with the same name. So while creating the bucket, it will check whether under the same name you have any other bucket under the same name. If yes, it will throw an error. Already a bucket name is existing. You want to type a name which should be unique. Okay. So here, these are all then when you use S3 for real-time applications, when you use Glacier for batch processing, for example, in a healthcare industry. So the healthcare industry need to maintain the records of all the patients. Okay, they may need to maintain the scan reports. They may need to maintain these reports of the treatment given to this person. A person may visit the hospital from 2000 onwards. Okay, now it is 2017. Historical data associated with the patients, the scan reports, okay, X-ray reports. So need to be maintained there. Here, for that they make use of Glacier. Okay, under Glacier, they can store all the archive copy. When a patient come now, okay, so if the doctor needs the old document, then he may initiate a request to the Glacier, and the Glacier, from the Glacier, the concerned scan or X-ray or the previous reports can be downloaded. Okay, then it can be make use of it. So here this sort of application can withstand delay. It is not mandatory that immediately when a patient get an appointment, initially patient need to get an appointment with the doctor. Once the patient appointment has been fixed, the doctor will initiate a request for the old information that has been stored in Glacier. Then those information will be downloaded within 2 to 4 hours according to the size. And once the patient appointment time is ready, then the doctor can have access to the data. Similarly, so if you want to store some documents which is not going to be modified any further, so the thing is that those documents, data which is not going to be subjected to any further modification. You can't modify a scan, you can't modify a X-ray. Similarly, if you are having a building plan, okay, so the building plan, any other plan, engineering drawing, okay, so it need to be maintained. Okay, so these sort of applications can make use of uh, Glacier because of low cost effectiveness. Okay, because of low cost. So if you need data in real time, then Glacier is not a supported thing. Okay. So if you are looking for a real time read write, then S3 is the supported thing. So within S3 also, there is an option for storing your data in a less cost. You have several options. Okay, like reduced redundancy and infrequent access. These are all two main options. RR stands for reduced redundancy storage. IFA stands for infrequent access. So it will have a less cost. So you have a default storage, okay, a normal storage. So then if you want, you can store your data in a reduced redundancy, and if you want, you can store your data in infrequent access. While discussing with S3, I will let you know the in-depth differences between reduced redundancy and NFA. But layman point of view, if you store the data, the cost will be less compared to storing the data in the default normal storage. If you want to still reduce the cost, then Glacier is the option. If you almost 1:10 times. If you want to spend here 10 rupees, here in this case it may be 8 rupees or it may be 7 rupees in reduced redundancy or infrequent access. If you want to reduce further, then it is the charge. Okay, I am making sense. Normally, how they will organize data in real-time applications, how they will organize data. So the data will be organized under the following manner. Initially, the data will be stored in S3. Okay. Then laterly, from S3 default, the data, we will write a script so that once the data is not accessible, then it will be moved to infrequent access. And from the infrequent access, after some duration, it will be moved to Glacier. And it will be retained there in Glacier. And if you don't want further, you can drop the data, remove the data. Okay. So this is the way by which the data from S3 will have a workflow moving into infrequent access. I need to specify data need to be in S3 for 60 days, first 60 days. Then if the data is not accessed frequently, let me move the data to infrequent access. Why so? Because the cost will be less. It may be there for another 100 days. And after that, after 160th day, you move the data to Glacier and let the data be there for 200 days. And after that, you simply drop the data. This is the flow associated with moving the data from S3 into Glacier and laterally dropping the data. So you can store data in S3 and you can write a script to move data in the manner, or you can directly upload or you can directly download the data from Glacier itself. Okay, so these are all the two ways by which you can do this. The key thing is that you no need to associate with the instance. If you want, you can associate. Certain applications may associate with the instance. Certain application may not need to associate with the instance. So in this case, if you are going to share the data alone, so you have a lot of video files. So you can store your video files in S3. And once the files has been stored in S3, a URL will be created. You can share the URL to the guys to whom you need to share the data. Under that case, you no need to associate with an instance. If you want to do some analytics on top of the data stored in S3, now your application that is going to do analytics may be running in your EC2 machine. Under that circumstance, the EC2 need to be associated with S3. You have data in S3, your application may be running in EC2, the data will be fetched from S3 into this EC2 instance, and you can do the needed process on top of it. Therefore, whenever the necessity arises according to your application need, you can either connect with S3 or you can either directly access S3 without any connection. The same thing for your Glacier also. Okay, so in S3 you have bucket, whereas the same thing in Glacier you have a vault. Directly in Glacier you want to create a vault similar to that of bucket. The vault name also should be unique. Then you can upload the object into the vault. Okay, so in OS terminology, which is nothing but you have a directory. Under directory, you will be having files, multiple files. Okay, the same concept here. Now, the last type of storage, EFS, that is a file system storage. If the storage want to be shared among multiple EC2 instances, and if the storage need to be dynamic, okay, so these are all fixed. You create a S3 and you upload the data into the storage. So you create a EBS or you create a instance store, then you need to specify the storage size. So if multiple EC2 instance, okay, so it is similar to your file server. You have files in file server, multiple machine can share the file. Similarly, here too you have data in your EFS, elastic file store, then multiple instance can access this store, okay, access this data, and they can able to share the storage space. Okay, this is EFS. So these are all the 5 types of storages and the associated differences. Our discussion today is going to be with this EBS, Elastic Block Store, and we are going to discuss about this S3. Okay, so if you have any doubt up to now what we have discussed, you can clear before proceeding further. We are going to start with EBS. If you have any doubt,
Okay, Raman, I have a query actually.
yes.
Yeah.
Now what I am going to do here is, this is the activity that I am going to do now. So I am going to create an instance. Okay, maybe any instance. Ubuntu instance. So here I am going to yeah,
It's very noisy, Raman.
so here now okay.
Yeah, okay. Yeah.
Here the Ubuntu instance by default will be assigned 8 GB of hard disk. Being it is a micro instance, what I am going to do, I am going to create a hard disk for 2 GB, a new hard disk. I am going to attach the hard disk to this Ubuntu instance. Okay, this is my EC2 Ubuntu instance. I am going to do how to attach and laterly how to detach. The basic activity that I am going to do now. Okay, you can attach any number of hard disks. So here I will let you know how to attach and how to access those hard disks and the associated data. Okay, so let I now connect with my account, a cloud account. So here I am already having these instances. So okay, Ansible, Docker, Maven. Let I launch another instance for our lab. I am going to make use of any instance. Okay, so either Amazon Linux or So that you know the steps. I am going to choose a micro instance, being it is free. So I am going to launch number of instances 1. So here itself you can add a new volume. There are two ways by which you can add a new volume. Here itself you can click add a new volume. Now you can find by default the volume is EBS. Okay, you can choose this EBS and you can add a new volume. Now you can find device SDB. Okay, here you have the same size. If you want, you can define your size. You can define your volume type, SSD or normal hard disk or magnetic storage like this. Okay, at the time of creation itself, you can specify whether the data need to be encrypted or not. Okay, if it need to be encrypted, you guys aware of encryption and decryption. You will generate a key. Based upon the key, the data will be encrypted. Yes, you know what is encryption and decryption. To store data in a secured manner, the data need to be encrypted and decrypted. That means, so you have this concept is coming under the network security, the computer network security. So here the general terminology is under cryptography. You will be dealing with this. So you have two algorithms called encryption algorithms, and another algorithm is decryption algorithms. So what this algorithm will do, you have your data, that is your plain text. PT stands for plain text. So this plain text, this is at the sender side. Okay. If the sender and receiver want to exchange data in a secured manner, then these are all the properties that need to be supported. It should have a data confidentiality. It should have integrity, data integrity. It should have the user authentication. These are all the three key features that need to support for a secured communication or for a secured storage, for both the things. If you want to store the data in a secured manner, you need to alone access the data. Others shouldn't able to access the data. Also, if you want to share the data among these two entities, this is your source, this is your target, that is your sender and receiver. You can specify either a sender or a receiver. Okay, this is a sender or a receiver. If a sender wants to transfer some information to receiver in a secret manner, then these following three features need to be adapted. So you call this as a plain text, the original text as a plain text. Let me make it this text as an attack. Okay, attack at 9 a.m. This is the message that need to be communicated between the person Ram and Amar. So Ram and Amar need to exchange some secured information, the secret information that need to be communicated. Here we have a group of attackers. If the information is sent as it is, attack at 9 a.m. Okay, to Amar, they may crawl the data intermediately. They may aware of what secret information it is. To overcome from that, what we need to do, we are going for a concept called encryption. Okay, so here the plain text is applied to this encryption algorithm. The encryption algorithm will have a key. Okay, the plain text will be converted into a CT called as a ciphertext. We call this as a ciphertext, which is an unintelligible format. Then this ciphertext will be transmitted in the medium. Okay, if attacker intermediately captures the ciphertext, he couldn't make any sense out of it. Also because the ciphertext will be in an unintelligible format. At the receiver side, once again, at the receiver side, the data, that is the ciphertext, is fed to algorithm called decryption algorithm. The decryption algorithm also uses the same key. Then the ciphertext will be revert back to the original plain text. Okay. Here the key which is used at the sender side and the receiver side is known only to the Amar and Ram. Apart from Amar and Ram, no other person will know the key. Okay. So how you ensure this data confidentiality, integrity and authentication? So here, if Amar sends a data, then Ram sends a data. So Ram will encrypt the data using the key and the data will be transmitted. Being Amar alone knows the key, Amar alone can decrypt the data. Okay, he will apply the decryption algorithm. He will know the key. Using the key, he can able to get back the original plain text. Okay, so in terms of this key has been concerned, there are two types of keys. Okay, there are two types of algorithm. One is a symmetric key cryptography. In terms of this key, one is a symmetric key cryptography, and second one a public key cryptography. The thing that we are discussing with respect to this cloud is a public key cryptography. A symmetric key cryptography is one for both encryption and for both decryption. The key is same. Okay, RAM as well as Hammer uses the same key. It won't have any difference in the key. Whereas in public key, so each and every user will maintain two keys. Okay, one key called the public key and another key called private key. One key called public key, another key called private key. We can make it using K of U and K of R. KU stands for public key, KR stands for private key. You have a public key for RAM, also a private key for RAM. Similarly for Amar 2, you have a public key for Amar and you have a private key for Amar, KR of Amar. Okay, so these are all the ways by which a symmetric a public key, otherwise called as a asymmetric cryptography. Okay, so let I take this example. Attack. RAM is sending this information, the plain text attack. When it's subjected to this encryption algorithm, it will convert it into ciphertext. Let me be D. W. D. G. N. So this is the ciphertext. Is it making any sense? DWWDGN. If attacker captures the data, it doesn't make any sense. Also because it is mapped into an unintelligible format using a key. This ciphertext will apply to decryption algorithm. When you apply key Amar, then you will get back the original message. Okay. Similarly, while storing the data, you can store the data by applying the key into a ciphertext format. You can store the data into a ciphertext format. While reading the data, you apply the key and to get back the original data. So that is the way by which you can secure it. Okay, here it asks you for a key. If you want to encrypt, you want to choose encrypt. If not, well, if you want to encrypt, you need to generate a key. Okay, then using that key, the data will be encrypted. So if any attacker try to penetrate into the particular storage, and if we try to make a read, it doesn't make any sense what it is stored. Also because being it is an encrypted format. Okay, so how you can ensure this data confidentiality? How you can ensure this data integrity and authentication? Now you know what is encryption, what is plain text, and what is the ciphertext, and what is the use of decryption. Okay, data confidentiality is a feature which ensures that the data need to be accessible only by the legitimate target people to whom it is addressed. Okay, so if you have in this group RAM, let me take this. Okay, here imagine that in this group you have a RAM, you have Amar, you have Kannan, sir, 5 minutes பேசுங்க கிளாஸ்ல இருக்கே முடிச்சிட்டு போய் ஓகே thank you. You have a Amar, you have a Kannan, okay, so you have other guys Balaji, Bhaskar. I want a particular information need to be shared with Amar only. Other person should not able to access this information. How I can ensure that? Okay, here that thing is data confidentiality. The data that is transmitted by RAM to Amar can be accessible only by Amar. Other people couldn't make access to the data. Ensuring this property has been termed as data confidentiality. Okay. Then what is integrity? So here, so for ensuring data confidentiality, I need authentication. Whether the message is sent, I send a message to Amar. Amar, give 10,000 rupees. Okay, to Balaji. Then Hammer want to get the assurance. This message of giving 10,000 rupees to Balaji, whether it is arised from Ram or anyone pretended to be Ram, saying that I am Ram, send him 10,000 rupees. Okay, so for that I need a assurance that Ram alone is instructed, Ram alone send the message. For that I need authentication. Okay, we have several authentication mechanisms using which we can authenticate the legitimate, whether the user is a legitimate user or he is a pretended user or not. Then once it is authenticated, then the data, if it need to be viewable only by Amar, then I need to ensure this property by data confidentiality, ensuring that to whom the data is addressed, apart from that user, no other people can able to view the data. That is data confidentiality. And what is data integrity? If I say 10,000 in that message, when it reaches Amar, okay, it should be 10,000. If any guys add another zero, it will make it as 1 lakh. So that is, you want to ensure that data which is received by the receiver is the original data sent by the sender. That is, without any modification, the data is received by the receiver, ensuring that property has been called as data integrity. By using these two keys, public key and private key, we can able to achieve these things. Okay, so here you can store data in a secure manner, we can communicate data in a secure manner. So for that, in our AWS we have a service called the KMS, Key Management Center, KMC. We can generate the key and key can manage using key management. You can do all the above activity. A small example how you can ensure data confidentiality and data integrity. Okay, so assume that Ram and Amar need to make a communication. Okay, here we have keys associated with. So Ram may have a public key, K of Q of Ram, and Ram will have a private key, KR of Ram. Similarly, Amar may have a public key, KU of Amar. Amar may have a private key, KR of Amar. For each and every user, Balaji may have KU of Balaji and KR of Balaji. Similarly, Bhaskar may have a KU of Bhaskar and a private key of Bhaskar. So in these circumstances, public key crypto systems. So here, one key will be made public. That is, the public key will be made public. All peoples in this communication group aware all other people's public key. And the private key is known only to the user. Only to the user. Apart from the user, nobody aware of the private key. Okay. So here, in our banking example, we have multiple lockers. So here for locker, we have two keys. So one key will be managed by the manager. That key is common to all the locker. The key which is retained by the manager is common to all the locker. Then the key that is shared to us will be unique. The key shared to Raman, we cannot use to access the locker of Bhaskar or the locker of Amar. Okay, am I making sense? The one key will be public. That is common to all the locker. Similarly, so each and every user will have a public key. That public key is known to all other people who form the part of the communication network. Okay, the Raman's public key is known to Kannan, Balaji, Bhaskar. Vice versa. Kannan's public key known to all other users. Now, a private key alone need to be retained in a secured manner. Ram's private key is known only to Ram. A Kannan's private key only need to know only to Kannan. Apart from Kannan, no other should know the private key. Now, how I can ensure this feature using this concept that I explained. This is interview perspective, it will be more value added. Okay, so you need to aware in a single manner. I can specify. You just create a key and put it in your storage. It will be highly secure. But you should aware of the underlying concept behind that. That's the reason why we are going in depth. Okay, now Ram is generating a message. Here we have Amar. I am going letting you know. We have Amar. Apart from that, we have here Balaji. Here we have Bhaskar. So Ram want to send the message to Amar. Amar will have the following keys. Amar will have a public key of Amar. Amar will have a private key of Amar. Amar also knows the public key of Ram. Similarly, Ram is having his own public key of Ram, private key KR of Ram. Also, he knows the public key of Amar. So it is generating the data. Let me make it the original message. M stands for original message. Ram, what he will do is going to encrypt the message with the public key of Amar, and the message will be converted into a ciphertext. Then this message will be transmitted in the medium, and at the receiver side, the ciphertext will be applied to a decryption algorithm. Okay, here Amar, when a message, what is the relationship between a public key and private key? The relationship between a public key and private key is such that if a data is encrypted using a public key, then the data can be decrypted only by its associated private key. Such a relationship exists between a public and private key. Okay, if the data is encrypted using a public key, that can be decrypted only by its associated private key. So in this case, being Ram aware of the public key of Amar, he encrypts the data using the public key. Now it forms a ciphertext, and the data will be transmitted here. Who alone can decrypt the data? Being the data is encrypted with the Amar's public key, Amar alone aware of the private key. So Amar we will decrypt the data by using the private key. Okay, the ciphertext will be applied to decryption algorithm using the private key of Amar. It will give back the original plain text. In this sense, which feature is ensured here? The feature that is ensured here is data confidentiality. How it is ensured? So when the original message is encrypted using a public key of Amar, that message can be decrypted only by the private key of Amar. So Amar alone will knows the private key. Balaji or Bhaskar doesn't aware of Amar's private key. Therefore, whenever Balaji or Bhaskar try to read the message being it is in encrypted format, they doesn't aware of what is what. Only the key, when you apply the key, private key of Amar, then that original message will be get back. So this is the way here the RAM, the intended user is Amar, that we ensure that apart from other, Balaji and Bhaskar couldn't able to view the information. That is called data confidentiality. So how Amar came to know that the message is coming from Raman? Here we need a data user authentication. You need a user authentication. How you can ensure this authentication? The reverse. If Ram send a message encrypted by its private key, this is a KR of Ram. Okay, it will convert it into ciphertext, and the message when Amar, what Amar will do? Amar will decrypt the message using the public key of Ram. The ciphertext will got the original message. So when he got the original message, that if the public key of RAM, using the public key of RAM, if Amar can get the original message, then it is assured that the message is encrypted only by using the private key. Who knows the private key of RAM? Apart from RAM, no other knows the private key. By the way, Amar can have assurance that this message is coming from the legitimate RAM only. So by the way, Amar can ensure a user authentication for this request. Okay, that message is readable to not only Amar, so the message can be readable to Balaji, Bhaskar, doesn't matter. But those guys need to have a assurance that Ram alone sent the message. Okay, in real time, you will combine both the thing. Okay, first the message will be encrypted using the public key of Hammer. Okay, and this is encrypted using the public key of Hammer. And laterly, the message will be encrypted using the private key of RAM. Two-way encryption. Therefore, the ciphertext will provide both data confidentiality as well as data authentication to the end user. This is the real-time applications which applies both the key. First, it will encrypt the public key of Hammer. Then, when it is encrypted with the public key of Hammer, it can be decrypted only by the private key of Hammer. So, we ensure data confidentiality. Laterly, it is encrypted with the private key of RAM. And if it is encrypted with the private key of RAM, then it can be decrypted only the public key of RAM. Here, it ensures data authentication. These are all the ways by which you can able to transmit data. At the same time, you can able to store the data. Okay. So, this is the concept behind cryptography. We are applying cryptography for authenticating the user. So in our EC2 instance, what Amazon did, well, if you launch a EC2 instance, what Amazon will do, Amazon create a public key and a private key. Amazon will retain the public key. It will give the private key to us. Each and every time when you try to connect with the instance, you need to submit the private key. The private key is matched with the public key. If and only if both the key matches, then Amazon can have assurance that then here Raman, for example, the Raman who is the owner of the instance is accessing the instance. Okay. By the way, Amazon assures that authentication. The original user is requesting for a connection with the instance like thing. So these are all the concept behind security. So if we can make use of this public key algorithm for data confidentiality and data authentication. Okay. So here in this example, if you want to store data in a secured manner, then you can create a key and you can encrypt the data using that key, and you alone can able to decrypt the data. So here the concept of creating key and managing key will be done by a service called the KMC, Key Management Center. Okay, which is beyond the scope of discussion. What I need to convey to you is you can store data in a very secured manner. If you uses a S3 or any EBS volume, you can store data in a secured manner using the concept of encryption. Okay, that is my intention. Is it making sense, guys?
Yeah, Raman, I have one question here.
Okay, so now we are going to add a tag. The tag name is main. Value is, let me make it once again, Singapore server. Okay, so configure security group. Let I create a security group, SG security group underscore Singapore server 1. Okay, so which permits SSH coming with port number 22 from anywhere. Review and launch the instance. It prompts you for a key path. So I am going to make use of my existing key path, Mala 6. Okay, so let I launch my instance. So here, one thing that you need to make a note of it while creating a volume. Okay, so here if it is a EBS based volume or an instance store volume, it depends upon the AMI that you are choosing. Okay, if you want to choose an instance based AMI, then you will be creating an instance store instance. Okay, I will show you how to create it. Now my machine is ready, Singapore server. Let I connect with this machine, copy, SSH, I need to authenticate, browse, I give my key, open. So being it is a Amazon Linux, the username is EC2-user. Okay. Now I have a EC2 instance with Amazon Linux, and my hard disk of my instance, the command is sudo fdisk -l. Will have a hard disk of 8 GB. You can find the hard disk of 8 GB Linux file system 8 GB. You can make a verification here too. So choose your instance. Here go to the property tag, which is downwards. Now you can find the instance is launched in US East 1D. That is your availability zone. Okay, the hard disk associated with the instance, you can move down. You can find you have a root device and you have a block device. Okay, the root device is one which containing operating system. The additional disk has been block devices. Since you have only one machine, both the root device and block device is system you the same thing. Now you have only one hard disk. If you click on this hard disk here, you can find the information associated. Each and every, this is a EBS volume. Okay, Elastic Block Store. The volume ID is this ID. Okay, it was created and attached during 72. Today is the time it got attached. Okay, the status is attached. Now you can find under this. You click on this volume. Let me make it 326. Click on volume under EBS. Now you can find 326 the volume where it is 326. Now you can click on the volume name 326. Now you can find the attachment information. It is attached with Singapore server 1. The attachment information showing that this volume is attached with Singapore server. Okay, these are all the informations associated with the volume. Now we can find the status of the volume was found to be in use. That is the key thing. The status of the volume was found to be in use. Now what we need to do, so here you can find another volume, a Raman hard disk, your status was found to be available. This shows the volume is available. If you don't want that volume, then you can go choose the volume and you can go to action and you can click on delete volume. So I had created a volume previously, I had deleted the volume. You can find the status deleting. Once it is deleted, I no need to pay for that. Okay, now the Singapore server is having a hard disk of 8 GB. Okay, so here the volume name is sing_server1. What I am going to do, so now I am going to create a new volume for any 3 GB or anything. Okay, so and laterally I am going to attach this volume to the Singapore server. Okay, so we have verified this using the board thing. Okay, we have issued this command to list the current volume attached sudo fdisk -l by connecting to a EC2 instance, and it shows you have only 1 GB of hard disk. Now how to attach this thing? So before attaching this volume, before creating a volume and attach the volume to the instance, the prerequisite is both the instance and the volume that you are going to attach with the instance need to be in the same availability zone. So you want to be very careful in this sense. You go to the instance and choose the instance Singapore server and verify under which availability zone that it is launched. The availability zone is US East 1D. If you have your instance in one availability zone and if you create a volume in another availability zone, you can't attach the volume to the running instance. That is the key thing here. Both the instance and the volume, EBS volume, need to be under the same availability zones. Okay, please make a note of it. So let us create a volume. Go to here, you can find the EBS, Elastic Block Store tag. Under this you have a volume. Click on volume. Here you can click on create volume. Click create volume. You can choose the volume type, a general purpose, a provisioned IOPS. Okay, we have different options. We no need to go up with these options. Let me go by default a general purpose a solid state device. Then by default, okay, you 100 GB has been allocated. So you can allocate a volume minimum of 1 GB and maximum of around 16,384 GB. A single hard disk can be of size around 16 terabyte. Starts from 1 GB minimum to 16 TB maximum. Okay. So now let I create a volume for 2 GB. I specify a size 2 GB. Okay. So here there is an option called availability zones. You need to create the volume in the same availability zones where your instance is running, to which you are going to attach. Here the availability zone by default it is showing is US East 1A, but your instance is running in US East 1D. Therefore, you want to create the volume by choosing the availability zone as US East 1D. Click on availability zone, go to US East 1D. So choose this one. Now your volume as well as your instance will be in the same availability zone. Okay, so while creating a volume, there is an option of using a snapshot. Snapshot is nothing but a backup of your instance. If you already have a volume containing some data, if you want to create a new volume with the same data, you can specify the snapshot ID. These are all the snapshots that has been already created. Okay, so if you want to restore from the existing hard disk, you need to go for snapshot. Since we are going to create a new hard disk, no need to go for this snapshot, keep as it is. Now you have an option, encryption. If you click on encryption, it prompts you for the master key. You can find a key management center. Okay, you want to go to this key management center and using this key you want to go for. So here I am not interested in going up with this concept as of now. You just uncheck it. No need to encrypt. Let me create a volume. Okay, add tags to your volume. I want to add a name to my volume. Click on tag. So the name is, I am going to assign name. The value is Singapore server hard disk 2. Singapore server hard disk 2. This is the tag that I am going to assign to my volume. Okay, so add. Now create a volume. Once everything is perfect, what do we need to do? Only two things that is mandatory. You want to specify the size of the volume and you need to choose the availability zone. All other options. Okay, create volume. Volume created successfully. Close. Now we can find a volume Singapore server hard disk 2 has been created, whose size is 2 GB. Here the created date is 17. The status of the volume was found to be available. Okay, now the attachment information was found to be empty. Volume status is perfect. So here there is no encryption. Okay, if it is encryption, the associated keys will be listed here. Okay, so this is the way by which you create a volume. Okay, and the volume status is found to be available. Now what we are going to do? So we have created a volume for 2 GB. Okay, so initially I had created an instance, EC2 instance in the same availability zone, US East 1D. Also I had created a new volume, a hard disk under the same availability zone for 2 GB. Now the EC2 instance, the existing volume for EC2 instance is 8 GB. So now I am going to attach this, the 2 GB with this EC2 instance, and I am going to verify whether it is attached and laterally detach. So I am going to perform the action of attach and detach this EC2 volume. Okay. Go to the dashboard. Here you choose the volume that you want to attach. Now verify that its state is now available. You can make a verification here. The state is available. Choose the volume. Go to action. So you have an option of delete volume, attach volume, modify volume, create snapshot. Okay. So if you want to increase the size of the volume, you can click modify volume. So you can increase the size by additional thing. If you have data, you couldn't able to decrease. Okay, if I try to decrease volume size, so the volume size can only be increased, not decreased. Okay, so that is the concept here. You can make it a 3, no issue. You can retain as it is 2, but you can't able to decrease the volume. Kindly make a note of it. So that is the option, first option, modifying volume. You can increase the volume. Create a snapshot. You have a volume. If you want to take a backup copy of the volume, you can create a snapshot. Snapshot is nothing but a backup copy of your volume. Okay. The third option. If you don't want this volume, you can remove the volume by simply click on delete volume. Okay. Delete volume will remove the volume. The fourth option is attach volume. Okay. You can attach this volume to a existing instance. This is the activity that we are going to do. If you don't want, you can detach the volume. So you can attach or you can detach the volume. Then you have another option called forced detach volume. What's the difference between a detached volume and a forced detached volume? If the volume containing some data, if some of the instance is using the data, if you detach the volume, it won't allow you to detach. Under the circumstances, you need to go for this option of forced detach volume. Okay. So this is the way by which either you can use detach or forced detach. Forced detach, what it will do? It will kill all the requests which is currently accessing the volume, and it will forcibly remove the volume. Now my intention is to attach the volume. Therefore, choose the volume, go to action, click on attach volume. Now you have the volume created in US East 1D. Now you can find another tag, instance, in US East 1D. That means if you click on this particular text box, it will list all the running instance in that particular availability zone. Now I am going to click it, click. Now we have only one instance, Singapore server 1, which is running in that particular US East 1D. Okay, all other instances may be in US East 1C or US East 1A. Let me make a check later. So only one instance that is running, I click on this instance, Singapore server 1. Automatically, once I chose that instance, the instance ID will be allocated here. Now the device, the attached hard disk is SDF. Okay, you can have hard disk attached in this manner, starting from F to P. F, G, H, I, J, K, L, M, N, O, P. 11 hard disk can be attached in this manner. Please make a note. Okay, your primary disk. Apart from that, you can attach 11 hard disk externally to a particular instance in this manner. Okay, the hard disk name is SDF. SCSI disk. F stands for hard disk. Let me attach here. Click on attach. Now you can find immediately the status become in use. Initially it was unavailable. Okay, when you create a volume and if you didn't attach that volume, the volume status was found to be available. Now the status, once it is attached, it will make converted into in use. Now you can find initially the attachment information also found to be empty. Now you can find the attachment information, it's listed with the instance to which it is attached. This is the instance ID to which the volume has been attached. You can verify the same thing. Click on the hard disk, go to the property down. Okay, these are all the properties. You can verify the attachment information that it is attached to Singapore server 1. Yes, making sense? Now let me verify whether it is attached or not. Go to instance. Choose Singapore server 1. Move down. Here initially you have only one root device, only one device, block device also only one device. Now we can find there are two devices. One is the newly attached device /div/stf and the original device /xvde. If you go to the volume, click on volume, and if you check that Singapore server hard disk 2, now you can find the attachment information. It is attached with Singapore server 1. Okay, this is the way by which you can create a volume and you can attach the volume. You can also verify using the same command that you have used, sudo fdisk-l. Now it shows there are two volumes. So one with 8 GB and another with 1 GB. Okay. So this is the 2 GB. This is the device, the 2 GB, and this is the device with 8 GB. You have two things. Okay, 8 GB volume and 2 GB volume. This is the way by which you have only a volume has been attached. You have to format this. You can format and you can mount the volume once you formatted these informations, starting, ending cylinder, file type, everything will be listed. Just you can find it contains the hard disk that is come original with the instance 8 GB and the hard disk that we have created 2 GB. Okay, so this is the way by which you create a EBS volume and attach the volume. How to detach? Very simple. The same reverse process. Okay, go to this hard disk. Go to action. Okay, now I can verify. Under instance, under Singapore server, you have 2 hard disks, hard disk 1 and hard disk 2. Under volume, you can find the Singapore server hard disk 2 status is found to be in use. Okay, the status is found to be in use. And you have attachment information of your instance ID. I am going to detach. Choose this hard disk. Go to action. Okay, detach volume. Simply detach. Yes, detach. Now my status from in use will be changed to available. It is currently detaching. Click on refresh screen. Now you can find the Singapore server hard disk 2. The status is available. Now the attachment information was found to be empty. If you go and check the instance, click instance, choose the instance Singapore server 1, hold down. You can find the hard disk has been removed under block device. You have only one hard disk. You can also verify the same thing. So once again, you issue the same command sudo fdisk-l. Now this command sudo fdisk-l list only one hard disk. That is your 8 GB. It won't list this hard disk 2 GB. It won't list this hard disk. This is the way by which you can create a volume and you can attach the, you can add the, you can go and add the volume. If you want to add the volume, you can simply add. Okay, if you want this volume to be attached to any instance, that is possible. Okay, you can find all other instances are running under 1C, 1C. That is not, these instances have been not listed. We have only a Singapore server which is running under US East only, that alone is listed. If I want to attach it with another instance, no issue. Launch an instance, that I launch another instance, Ubuntu. Configure instance detail. Okay, so here, this is the default VPC and this is the subnet. I need to choose a subnet US East only. Okay, so add storage, that I add a tag, that I add a tag to my instance, name is, that I make it as Singapore server 2. Configure security group. I'm going to make use of the same security group, review launch. I'm going to choose this volume Mala launch instance. View instances. Now you have Singapore server 1 and Singapore server 2. Now I had created a hard disk and attached the hard disk to Singapore server 1. Now I have detached the hard disk. I am going to attach it with another server. Okay, is it possible or not? Let me verify. Choose Singapore server 2. Now we can find the root device is only one device /dev/sta. Now both the machine is created under the same availability zone. Okay, so here what I am going to do, I am going for this volume. Click on volume. Choose the volume Singapore server 2. That is the volume that is in use. Singapore server hard disk 2. Choose the hard disk. Go to action. Let I attach the volume. Click attach. Now if I click here instance, it will list 2 instances. One is Singapore server 1 and Singapore server 2. Let I choose Singapore server 2 and let I attach. Just got attached. Now the hard disk status become in use. go to instance, choose the Singapore server 2. Now you can find it is attached with the additional hard disk /div/stf. If you click here, now the volume ID is the following. The information is attached. So what I did is, so here initially created a 2 GB hard disk, and first I had attached the hard disk to my EC2 instance, that is Singapore underscore server 1, and I had detached it. Laterly, what I did, I had created another machine. The initially created machine is Amazon Linux. Now I have created another machine with Ubuntu. Okay, this machine at the time of creation containing 8 GB hard disk. Here the thing is that both this availability zone 1D and the hard disk availability zone is need to be the same. Here I created another machine, a EC2 machine with Ubuntu, and the detached hard disk I had attached with this instance 2 GB. Okay, so this is the way by which your hard disk, if it is a EBS volume, can act as similar to that of your external hard disk. Yes, it is making sense. You can attach, you can detach, you can play as you like.
Yes, it makes sense.
So you need to format, those are all admin's role. Okay, you can format, you can store data, so you can use the data across multiple instances. This is the way by which you need to create a volume. So if you don't have the if you don't want the volume, you need to pay for the volume, for additional volume. What I am going to do? So this is the volume that is created. Okay, 2 GB Singapore server hard disk. Go to action. Okay, you can find attached hard disk cannot be removed. You cannot delete the volume. What you need to do? First you want to detach the volume, and laterly you can delete the volume. So now you detach the volume. Yes, detach. Now the volume got detached. Now from in use, it will become available. From in use, it will become available. After that, you go to action, simply delete volume. So you can delete the volume. That's all. Now volume is not at all available. Now you have another hard disk. So the hard disk is attached with Maven Ubuntu. Okay, let I go to action and detach volume. Yes, detached. Now the status will become, once it is detached, now it is available. Go to action, delete volume. Okay, if I try to remove this server, okay, click on this Singapore server, go to action. You couldn't delete a volume if it is a root volume. The thing is that if it is an additional volume, we can remove the volume. If it is a root volume, and if you try to detach, it shows unable to detach root volume from the instance. Okay. Once again, it will show the following error. Okay. So go to action, force detach volume. Yes, detach. Once again, this force option is won't available for if it is a root volume. Why so? Because the volume contains the OS for that particular machine. Therefore, if you want to remove the volume, okay, if it is a root volume, these are all interview questions. You want to aware of this. What you need to do? Go to the instance and first you terminate the instance. Automatically, the volume will also be terminated. Once you terminate the instance, the root volume associated with the instance also terminated. If it is additional volume, then that volume can be retained. Root volume will be terminated. Now I am going to terminate this both servers, Singapore server 1 and Singapore server 2. Go to action, instance state, terminate. Automatically, once the server has been terminated, okay, the volume associated with this also will be terminated. Now the Singapore server 1 and Singapore server 2 Once the server is terminated, this volume also will be terminated. Okay. The next time if you log in, it won't list this volume. These are all the ways by which you can create a volume, you can attach the volume, and you can do the needed activities on top of it. Do you have any doubt? Is it clear?